Hey guys, this is Eric Miller. I'm here at M&M 2024 in Cleveland, Ohio. We're at the mega booth. There's a massive party going on right next door. And this is Joe from ConnectomX. And you had this really, your company had this really amazing new product come out last year. I thought it was amazing. But what's happened to it in the year since? And tell me about any sort of new developments you have.
Sure. So the Katana microtome is essentially a serial block face instrument. So the idea is that we cut a thin section of usually a life science sample, but also material science as well. And we're talking 30 nanometers, that sort of region, or up to 200 off the top of the surface. We image, we do it again, we image again. And the idea is that we build up a 3D model of our system. It's a volume EM technique similar to FIB, but the idea is that you have a wider field of view and you can cut a lot deeper. We're talking sort of hundreds of microns down.
Yeah, so I mean there have been other products that do similar things like that on the market, but yours is just, it's so small.
Yeah.
It's very small. So how big is it?
It weighs just over a kilo, and then yes, let me try and do American units for you. I couldn't even
1
guess.
kilogram is fine.
Yeah. And then we have 60 millimeters in height. So essentially, if you can fit that between your XY table and your pole piece, we can get in there and do some serial block face.
Okay, that's cool. So what sort of new things have you, improvements have you made just recently?
Sure. So not long after I came on, we started a project with the National Physical Laboratory in the UK. And we were looking specifically at the oscillator of our knife. What the oscillator does is essentially move the knife in a sawing motion. And that has the effect of reducing the cutting force, and it essentially gives you a smoother cut on your surface, so you have no topography. With National Physical Laboratory, we used a laser Doppler vibrometer, and we studied to sort of picometer, hundreds of picometer movements, the oscillator, and we essentially optimized for cutting quality, but also minimizing the effect of Z resolution reduction. So whenever you have a movement like this, you expect it's going to move a little bit like this. You're trying to reduce that.
All right. Okay, so if anyone's interested in learning more about your system, how do they find you online?
Yeah, sure. So they can come and contact us at ConnectomX.com. We're also on Twitter at ConnectomX3D. We're on LinkedIn. You can also come and just drop us an email at hello@ConnectomX.com.
Okay.
Any and all of the above.
Okay, sounds great. Okay, well, thanks a lot, Joe. That was really interesting. We're going to have some more from M&M coming up next. We'll see you then.